RNAV systems, how an aircraft flies a route. Area navigation is enabled by the use of an onboard navigation computer, referred to as an RNAV system, which may, or may not, have an integrated navigation database. The data in the database is specific to an aircraft operator's requirements. This data is taken from the state's aeronautical information publications in the form of route structures, operational procedures and navigation aids. The intended flight path is created by the pilot by selecting or inputting a series of waypoints using the nav control unit. The RNAV system defines the required flight path by linking the waypoints together. It uses the database, if fitted, to call up details of the waypoints to do this. With no database, the pilot must insert all waypoint data. The intended flight path is then displayed to the pilot on a navigation display. Simple RNAV systems will display the lateral deviation from the required track. If a map display is available, the RNAV system will display the intended flight path. The aircraft's position is calculated using positional information. This is received by onboard navigation sensors from either ground-based or space-based navigational aids, or by onboard inertial platforms. The coordinates of ground-based nav aids are taken from the database, if fitted. The accuracy and consistency of the aircraft's ability to fly the desired path is subject to the aircraft capabilities and onboard functionalities. RNAV system functionality. Not all RNAV systems are the same, however they are similar in basic functionality. An RNAV system integrates information received from sensors, inputs from its internal database and crew-entered data to provide navigation, flight plan management, referencing waypoints, not ground-based nav aids, guidance and control, display and system control. Select this activity for more. An RNAV system is designed and certified to provide a particular level of navigation accuracy with repeatable and predictable path definition. The navigation function computes data that includes aircraft position, velocity, track angle, etc. This data is displayed on the navigation display or a course deviation indicator and may be displayed on the flight director and fed to the autopilot. The flight plan management function uses the internal database to compute the reference path, defined path. RNAV system functionality content. The RNAV system provides lateral guidance by comparing the aircraft's position, estimated by the navigation function, with the defined lateral path to generate steering commands. Due to a number of factors, the defined path may not exactly match the desired path. The aircraft's actual position may not coincide with its estimated position. The required navigation accuracy of an aircraft must take into account all of the errors. This is referred to as the total system error.
Earlier in this topic, you learnt that the onboard navigation computer integrates various pieces of information to provide, amongst other things, a navigation solution and a flight plan management function. The computer estimates the aircraft position, calculates the velocity, the track, and so on, and provides this information to the flight crew on the avionic displays. The flight plan management function uses its internal database, if part of that navigation computer's functionality, to create the defined path. As we know, the database holds information about the ATS route structure, the location of the ground-based navigation aids, and a variety of other important data such as airspace constraints. The navigation computer then provides guidance to the flight crew by comparing the aircraft's estimated position to the defined path. However, there are errors in the RNAV system which need to be taken into account. Firstly, the defined path in the aircraft may not be exactly where the airspace planner or procedure designer desires the aircraft to fly. This error is called the path definition error and can be caused by the resolution of the computer and due to the unevenness of the Earth's surface. This error is assumed to be very small and is managed in the data chain. The second error is the difference between the physical true position of the aircraft and the estimated position in a fault-free environment. The accuracy of the position estimation is based on the performance of the navigation aid being used. This error is referred to as the navigation sensor error and, simply put, is minimized by using more accurate position sensors. VOR DME is not as accurate as DME DME, and GNSS is by far the most accurate positioning source. GNSS is the only navigation sensor that supports every navigation specification. NSE is sometimes also called position estimation error. The third error that must be taken into account is the ability of the avionics, or the pilot, to fly the aircraft from the estimated position onto the defined path. This error is referred to as flight technical error. The autopilot is considered the most accurate way to manage FTE, with manual flight using a course deviation indicator being the least accurate. FTE is sometimes referred to as path steering error. The combination of all three errors is known as total system error. The total system error is the difference between the physical, true position of the aircraft and the desired path that the planner/designer wants the aircraft to fly. When an aircraft is certified to a specific performance, the manufacturer has demonstrated to the certifying authority that 95% of the flight time the aircraft will perform with that required level of accuracy or better, all of the errors combined. For example, an RNAV-1 certified aircraft has demonstrated that 95% of the flight time, all of the errors combined, the aircraft can follow an ATS route with a lateral track accuracy of ±1 nautical mile or better.